Okay, so let's dig into this. Have you noticed how terms like AI agents and agentic AI are suddenly just everywhere?
Oh, absolutely. Yeah.
And if you've been hearing these phrases and maybe feeling, well, a little bit confused about what they actually mean or, how they're different, you're definitely not alone.
Right.
The interest seems to have just exploded, especially since like the whole ChatGPT era kicked off.
Yeah.
We even saw some search trend data in the material we're looking at today showing this big spike right around then.
That's right. And, before that big inflection point when people talked about autonomous agents, it was often kind of stuck in labs or very specific industries.
Right.
Think like old school rule-based expert systems or those early reactive robots, very predefined rules, super narrow.
Yeah.
And honestly, they just didn't have the learning or context awareness we kind of expect now with modern AI. The review we're looking at actually calls these the before ChatGPT era systems.
Okay.
Totally reliant on deterministic logic, really limited in how they could adapt.
So for this deep dive then, our mission is basically to take this source material, this really detailed review on the concepts, the applications, the challenges of AI agents versus agentic AI and kind of cut through the noise.
Yeah, makes sense of it all.
Exactly. We're going to pull out the key stuff to give you a clear picture, what these terms mean, where they came from, what they can actually do, and importantly, what the big hurdles still are. Think of it as like your shortcut to getting up to speed on this, well, really cutting-edge area of AI.
Absolutely. And maybe we should start with the basics, right? Like, what is an AI agent? According to this material, you can think of it as an autonomous software thing, an entity designed for goal-directed tasks.
Okay.
Usually it operates within pretty well-defined digital environments, sort of like your personal assistant maybe, but one that works on its own within a specific job or domain.
Okay, so a focused, sort of automated helper. The review mentions 3 core characteristics, I think it was figure 4, that define an AI agent. Can you kind of unpack those for us? What makes something an AI agent here?
Sure. The key things highlighted are autonomy, task specificity, and reactivity with adaptation.
Okay.
So autonomy basically means they can act independently after you deploy them. You don't need much human hand-holding. Think like a customer support bot handling queries on its own.
Right.
Task specificity is super important. They're built for narrow, defined jobs, filtering your email, maybe querying a database, coordinating calendar invites. They're really optimized for that one thing.
And you mentioned reactivity with adaptation. Does the source explain how they adapt? Is it like real learning or something simpler?
Well, the adaptation mentioned here seems to be more about basic learning through, say, feedback loops or simple rules of thumb heuristics. It helps them refine their behavior within that specific task. It's not necessarily, deep general learning like a human, but it's enough so they can respond to changing inputs, user commands, API data, things like that, and adjust themselves within their limited scope.
So what's giving these modern agents their smarts then? It's clearly not just those old school rules anymore.
No. Definitely not. That's really where foundational models come in, especially large language models, LLMs like GPT-4, PaLM, the ones.
Yeah.
And also large image models or LIMs like CLIP or BLEP2. These are basically the brains and often the eyes powering these modern agents.
Okay.
LLMs give them the reasoning, the understanding, the language skills, and LIMs let the agent actually perceive and understand visual stuff.
You mean they can literally see?
Well, in a way, yeah. Based on what the source says, it gives this great example, I think it was figure 5, of an autonomous drone inspecting an orchard.
Oh, right.
A limb lets that drone agent see diseased fruit or maybe damaged branches by interpreting the video feed, right? And once it spots something, the agent can trigger its protocols automatically, maybe alert someone, mark the GPS location.
Wow.
And these models, these brains and eyes, they're often accessed through APIs from companies like OpenAI, Hugging Face, Google. Makes it easier for developers to plug these powerful capabilities into their agents.
Okay, so it really sounds like generative AI, the early ChatGPT everyone started playing with, was a key stepping stone to get here.
Oh, absolutely. The review positions generative AI as a really foundational precursor. Systems like early ChatGPT were amazing at creating stuff, text, images, code, just based on a prompt. But critically, they were mostly just reactive. They only did something when you prompted them. They depended entirely on the prompt, and they were largely stateless, meaning they didn't remember things from one interaction to the next unless you explicitly fed it back in.
Right.
And crucially, they couldn't really interact with the outside world or use tools on their own. not without some extra code, some external components wrapping around them.
Okay, so generative AI reacts to a prompt, makes stuff.
Yeah.
But AI agents,
Yeah.
they add the ability to actually do things, like by using tools.
Precisely. That evolution to what the material calls tool-augmented AI agents, that's the really critical transition described here. These agents build on those language abilities of generative models, but they add extra infrastructure, things like memory buffers, ways to call tools via APIs, structured reasoning chains.
Okay.
We saw frameworks pop up like AutoGPT or Baby AGI that basically put LLMs inside feedback loops. So the agent could plan, then act using a tool, then look at the result and adapt its next step.
Makes sense.
The news query agent workflow example in the source figure 6 shows this perfectly. It uses an LLM to understand your question, figures out it needs current info, calls a web search tool via an API, gets the results back, and then uses the LLM again to put together an answer from those results.
Right. So that adds context for you, the listener, the chatbot you talk to on a website, maybe AI features in your email or scheduling app. The review clearly puts these in that tool-augmented AI agent box. Are there common pitfalls the source mentions for these kinds of agents we use daily?
Well, the detailed pitfalls come up a bit later when we hit the challenges section, but yeah, even these more capable AI agents definitely have their limits compared to what comes next. But this type of agent, automating specific tasks, acting on its own, using digital tools, you probably interact with these quite a bit.
All right, so we've got AI agents doing specific tasks using tools, but the source material talks about this leap beyond that to something called Agentic AI. What's the big difference the review is highlighting there?
Yeah, that's where this sort of conceptual leap happens. So while a single AI agent is great for one specific task, right, tackling really complex real-world goals often means you need to keep track of context over time, understand how different tasks affect each other, and adapt to really dynamic situations. A single agent built for just one job. It kind of hits a wall there.
And Agentic AI breaks through that wall. How, according to the material?
Well, Agentic AI isn't just one agent anymore. It's described as a paradigm shift. It's about systems made up of multiple specialized agents that actually collaborate to achieve these complex, high-level goals.
Okay. They work together. Right. They take a big goal, break it down into smaller pieces, communicate with each other, and coordinate what they're doing.
So it's less about one super smart agent and more about a team of specialists working together?
Essentially, yeah. A coordinated system of agents. The source uses a really helpful analogy. I think it's in Table I in Figure 7, comparing it to a smart home.
Okay, walk us through that. How does the single agent compare to the agentic system in that smart home scenario?
Okay, so on one side, you've got your basic AI agent, maybe like a smart thermostat. It's one thing. Designed for one task, managing the temperature.
Right.
It's got some autonomy within that scope. Maybe it learns your schedule or something, but it basically operates in isolation. It doesn't talk to your smart lights or the security system.
Right. Does its one job, hopefully well.
Exactly.
Yeah.
Now, according to this review, on the other side, you have the agentic AI system, the whole smart home working together. This involves multiple agents collaborating.
You've got maybe a weather forecast agent, a scheduling agent, an energy management agent, a security agent, and they aren't just reacting on their own. They're dynamically communicating, sharing information like sensor readings or calendar updates, and coordinating their actions together, aiming for a broader system goal.
Like trying to optimize comfort, but also safety and energy efficiency all at the same time.
Precisely. The weather agent might tell the energy agent, hey, heat wave coming. The energy agent talks to the scheduling agent, sees your home, and decides to pre-cool the house using solar before the expensive peak rates kick in.
Clever.
Meanwhile, maybe the security agent sees you're leaving later and tells the energy agent, hold off on running the dishwasher until they're back. They communicate, they share memory, they align their actions. That's the core difference highlighted in the source, that shift from isolated action, like the thermostat, to coordinated system intelligence, like the whole smart home ecosystem working together.
That makes a lot of sense. The material also breaks it down further, comparing them across things like architecture, scope, autonomy. I think those were tables 2, 3, and 4. It definitely seems like the complexity just ramps way up with agentic AI.
It absolutely does. The architecture shifts from, say, a single LLM plus some tools to a whole network of multiple agents, maybe with an orchestrator agent managing things.
Right.
The way they operate goes from a fairly simple prompt tool output flow to this complex orchestrated web of agents talking to each other, figuring out who does what. The scope blows up from a single task to handling complex multi-step workflows.
And how we interact changes too.
Yeah, the interaction shifts. Instead of you talking to one specific agent, you might interact with the system, which then coordinates all the agents behind the scenes. And autonomy goes from, medium within its specific task to potentially high, managing the whole complex process. The big takeaway from all those comparisons is really that fundamental shift from doing one thing well by itself to this collaborative, systemic intelligence built for complex, dynamic problems.
So where are we actually seeing these differences play out? The source maps out applications in Figure 9. Let's look at some examples, maybe starting with the single AI agents first.
Sure. For AI agents, the applications in Figure 10 are often about automating specific interactions or processes we already do. Customer support automation, Figure 10a, that's a huge one.
Yeah.
Agents answering common questions, sorting tickets, maybe using RAG retrieval augmented generation to pull info from knowledge bases, or connecting to systems like Salesforce via APIs, or even internal search agents helping employees find company documents faster.
And you mentioned scheduling assistants earlier.
Right. Autonomous scheduling assistants, Figure 10D, that's another good example. Agents plugged into calendars and email, they can understand requests like, find a time for us to meet next week, check everyone's availability using calendar APIs, juggle conflicts, and propose times automatically. Tools like X.AI or Reclaim AI fall into this category.
Okay.
The material also mentions things like email filtering or personalized recommendations as other common examples of these single task-focused agents.
Okay, yeah, those feel pretty familiar now. So what about the agentic AI applications? Where does that multi-agent coordination really start to shine, according to the source?
Right. This is where you see systems tackling stuff that needs multiple kinds of expertise or really tight coordination. Multi-agent research assistants, Figure 11a, that's a fascinating example.
Okay.
Imagine trying to draft something complex, like a big grant proposal. An agentic AI system, maybe using a framework like AutoGen or Crew AI, could have separate agents doing different parts. One retrieves relevant papers, another summarizes the key findings, another checks if the proposal meets specific guidelines, another formats the whole thing.
Wow.
And they're all collaborating, sharing information through some kind of shared memory, maybe coordinated by an orchestrator agent. It's really like a research team effort, but done by agents.
That is definitely way more complex than just summarizing one article.
Exactly. Or think about intelligent robotics coordination, Figure 11b. The review mentions drone swarms inspecting orchards. This isn't just one drone doing its thing, it's a coordinated system.
Mm-hmm.
Agents in different drones might be communicating, maybe sharing sensor data, identifying diseased trees together, mapping the whole area collaboratively, maybe even guiding human pickers to the right spots. They're all working together, sharing data, probably through some central memory layer. Frameworks like MetaGPT are mentioned as enabling this kind of structured, multi-agent collaboration, sometimes even modeling agents like different departments in a company.
It really sounds like these multi-agent systems are starting to tackle jobs that, well, previously just seemed way too complex or needed too much human back and forth to automate effectively.
Precisely. Think about tasks maybe in your own field or industry that involve lots of steps, different kinds of information, collaboration between different roles. That's the sweet spot where agentic AI is starting to make inroads. The source mentions things like collaborative medical decision support in ICUs or adaptive cybersecurity response, where different agents handle threat classification, compliance checks, and mitigation planning, all working together.
Okay, so they can potentially do a lot more, but I'm guessing they probably come with some pretty significant challenges too. The review maps those out as well, right? Figure 12.
Oh, they absolutely do. And the challenges are different for each type. For the single AI agents, Figure 12a, even though they're useful, they have some real limitations. A big one the review highlights is this lack of causal understanding. Meaning the LLMs powering them are great at finding correlations in data, like they see visiting a hospital and being sick happen together a lot, but they don't truly understand cause and effect. They don't get which one causes which. And that makes them brittle. They can break easily when things change or in situations they haven't seen before in their training data.
And they inherit all the, let's say, quirks of the LLMs they're built on.
Yes, that's another major challenge the source discusses. They inherit all the LLM LLM limitations.
Hmm.
Things like hallucinations, just making stuff up, which is obviously really dangerous in critical applications. They also suffer from prompt sensitivity. Small changes in how you ask something can totally change their behavior, making them hard to control reliably. And even with clever techniques like chain of thought or React to make them reason better, the reasoning can still be pretty shallow. Plus, you've got the ongoing issues of cost, latency, the fact their knowledge is often static unless you specifically augment it, and of course, the biases baked into their training data.
They also aren't fully agentic in the classic AI sense, are they?
That's a good point the material raises. They often have what it calls incomplete agentic properties. Their autonomy is usually limited just to their specific task. They're typically reactive. They wait for a prompt or an event rather than proactive. And their ability to interact socially or coordinate deeply with other systems or agents is pretty constrained. They also really struggle with long horizon planning, complex, multi-step tasks where they need to remember what happened, keep track of progress, and recover if something goes wrong. They can easily get stuck in loops.
And safety. That must be a concern.
Reliability and safety are noted as major concerns, yeah. They aren't really safe or verifiable enough yet for truly critical uses because you just can't guarantee how they'll behave, especially under unexpected conditions. Again, partly due to that lack of causal understanding.
Okay, so those are some serious challenges even for the single AI agents. What happens when you start throwing multiple agents together in these agentic AI systems? Does that make things easier or harder, according to this review?
It seems like it often amplifies the existing challenges, that's figure 12b, and definitely introduces new ones. That causality issue we just talked about, it gets amplified.
How so?
Well, if one agent makes an error or misunderstands something based on a faulty correlation, that error can cascade through the entire system. It can corrupt the work of all the agents that rely on its output downstream.
Like one agent getting a fact wrong and then every other agent just building on top of that wrong fact.
Exactly that. And communication and coordination. These become huge bottlenecks discussed in this source. Just getting multiple agents to understand the shared goal, know when it's their turn to act, how to share context effectively, and crucially, not step on each other's digital toes. It's incredibly difficult. There aren't really standard ways for them to talk to each other properly yet.
And with all that complex interaction, you probably get unpredictable emergent behavior.
Yes, exactly. And that's flagged as a big challenge for predictability in the review. You get these unexpected system behaviors popping up just from how the agents interact. Sometimes that might be good, maybe creative, but it can also lead to instability, agents working against each other, unintended consequences, or the whole system just getting stuck.
Right.
It's kind of like trying to predict the exact outcome of a really complex meeting with lots of strong personalities. The group dynamics can be hard to forecast.
And if something does go wrong in that complex web,
Debugging and scalability become nightmares. With multiple agents, and each one potentially being a bit of a black box itself, trying to trace the root cause of an error through that whole network of interactions, it gets exponentially harder. And just adding more agents doesn't automatically make the system smarter. Sometimes it just adds more complexity and noise.
so trusting these systems and explaining how they work must get even harder then.
Significantly harder, yeah. It's really difficult to know which agent did what or why the overall system arrived at a specific decision. And the review notes there currently aren't really formal methods to verify that a multi-agent system will reliably do what you expect it to do. This lack of trust, explainability, and verifiability is pointed out as a major barrier, especially for using them in high-stakes, safety-critical areas.
And I guess security risks multiply with more agents interacting.
Absolutely. The attack surface just gets bigger. If you can compromise one agent, you might be able to compromise the whole system. Or you could manipulate the communication between agents to cause the whole workflow to fail or produce bad results.
The review also brings up ethical and governance challenges, specifically for agentic AI, right? In figure 12b. How does that complexity play out there?
Yeah, the material states that these issues become much more complex too. Questions like, who's accountable when multiple agents collaborate on a bad decision? It notes that bias could potentially be amplified across the system, maybe if biased agents reinforce each other's outputs. And just aligning all the agents towards a single, complex, maybe evolving human goal, that's described as incredibly difficult, especially over the long term.
Wow, okay. Sounds like a lot of hurdles, definitely. The material even notes that the foundations for building these agentic AI systems are still quite immature. What does that mean for, say, developers or companies trying to build these things right now?
It basically means there's a lack of established standard ways to build them, standard architectures, and there are still significant gaps in the fundamental research, particularly around things like causal reasoning within these really complex, dynamic, multi-agent setups. The field is still actively trying to figure out the best practices for building and managing these systems so they're reliable and predictable.
Okay, deep breath. So, those are the challenges. They're pretty significant, but the field is moving incredibly fast. The material also outlines potential solutions and gives a kind of future roadmap. I think that was figure 13. What are some of the strategies being explored to try and tackle these issues?
Yeah, researchers are definitely working hard on several fronts. To help ground agents and cut down on hallucinations, retrieval augmented generation, or RG, is key. That means connecting agents to external, reliable, up-to-date data sources like databases or document stores.
Right.
Tool-augmented reasoning, basically enabling agents to use function calling, lets them interact with the real world via APIs or scripts, expanding what they can do beyond just their internal knowledge.
And for making better decisions, how do they tackle that?
Well, the idea of an agentic loop using patterns like REACT, which stands for reason, act, observe, allows agents to sort of iterate on tasks. They reason about what to do, take an action, maybe using a tool, observe the result, and then decide on the next step rather than just outputting a final answer immediately.
Oh, okay.
Memory architectures are also crucial. Developing ways for agents to have persistent memory, maybe episodic memory for task history, semantic memory for facts, vector memory for related concepts, allows them to retain context and learn over longer periods. This is really vital for complex tasks and especially for multi-agent coordination where they need shared understanding.
And for managing all those agents working together.
Multi-agent orchestration, often involving specialized roles for different agents, is seen as essential. Designing systems with maybe a central orchestrator agent managing specialized subordinate agents like planners, information retrievers, summarizers helps tame the complexity and coordinate the workflow. And things like reflexive and self-critique mechanisms are being explored. This means enabling agents, or maybe even dedicated critic agents, to review their own work or the work of other agents to catch errors and improve reliability.
What about those really tricky issues of predictability and safety? Any approaches there?
Yeah, there's work on things like programmatic prompt engineering pipelines, trying to automate how prompts are tuned to make agent behavior more robust and repeatable. But crucially, the review mentions causal modeling and simulation-based planning. The goal here is to move agents beyond just seeing correlations to actually understanding cause and effect.
Right, the hospital example.
Exactly. That understanding would allow for much more robust planning, especially in multi-agent systems where one agent needs to anticipate how his actions might affect others. And for governance, things like governance-aware architectures and building robust monitoring, auditing, and explainability pipelines right from the start are highlighted as necessary to ensure accountability, security, and transparency.
So the future roadmap then, figure 14, for the simpler AI agents, sounds like it's focused on making them more proactive and reliable within their tasks.
Yeah, essentially. The review envisions AI agents becoming more proactive, getting better at integrating and using tools, incorporating more causal reasoning, enabling continuous learning from experience, and really prioritizing trust and safety features. So they evolve from just being reactive helpers to more autonomous, adaptive partners within their defined domain.
And for Agentic AI, it sounds like scaling up the complexity and coordination.
Pretty much. The future described for agentic AI involves scaling up to handle more agents, effectively multi-agent scaling, developing better unified orchestration methods to manage these larger agent teams, enhancing persistent memory so they can tackle longer, more complex tasks requiring context over time, using simulation planning where agents might simulate different strategies before acting, and embedding stronger ethical governance frameworks right into the system architecture. The ultimate goal seems to be creating these tailored, domain-specific systems that leverage this collaborative agent intelligence for really complex, high-stakes problems in fields like medicine, law, science, or logistics.
Okay, so let's just try and bring it all back together then. Based on this deep dive into the source material, what's the absolute core distinction we should remember between AI agents and agentic AI?
I think the simplest way to frame it, based on this review, is AI agents are fantastic for well-defined specific tasks. They use tools, they act autonomously, but usually within a pretty bounded environment. Think of them as a really capable, specialized individual worker focused on one job.
Right. And agentic AI?
Agentic AI takes that concept much further. It's really about coordinating multiple of these specialized agents, getting them to work together towards complex, dynamic, high-level goals. It's less like that single worker and more like a collaborative team, or maybe even a whole organization of specialized units that have to communicate, manage dependencies, and adapt together to achieve a bigger, shared objective.
Yeah, this deep dive into the source has really helped clarify that landscape, I
Yeah.
think. It shows that clear progression from the simpler generative models we first saw to these individual task-specific agents using tools, and now towards these really complex agentic ecosystems that can potentially tackle much bigger, multifaceted goals. Understanding that taxonomy, that difference, feels absolutely key for anyone trying to navigate or, build stuff in this space right now.
Agreed. It really highlights not just what's possible today, but also the direction things seem to be heading.
And that brings us, I guess, to a final provocative thought, something for you to maybe mull over after this deep dive. The source material lays out this pretty clear path, right?
Yeah.
From single agents to these complex collaborative systems tackling big goals. But given those significant challenges we discussed that still remain, particularly around predictability, safety, and governance in these multi-agent systems, including the issues the source raises about accountability and the potential for bias to get amplified. What new forms of human oversight or maybe human-agent collaboration or even entirely new system designs might we actually need to ensure that these increasingly autonomous agentic systems genuinely benefit society safely? Something to think about as these systems keep evolving.